Okay, hello everyone. In this video, we are going to discuss about Laplace transform of a periodic function. In our last class, we have been discussed few numericals which are based upon unitary step function and second shifting theorem. In detail, we have been discussed, and I given three questions for you. Hopefully, you have been done these three questions. Now, we are going to start to discuss about Laplace transform of a periodic function. So if ft is a periodic function with period capital T, then Laplace transform of that periodic function f of t will be equal to integration limit 0 to t e to the power minus st into f of t dt by 1 minus e to the power minus st. That we are going to be prove here. So proof starts Laplace transform of f of t in general written as 0 to infinity e to the power minus st into f of t dt. Now here the limits is from 0 to infinite. So this limit can be written with segregate that 0 to t. 0 to t means the so-called period, whatever the given in the question. 0 to t e to the minus st into f of t dt plus t to 2t e to the minus st f of t dt, then 2t to 3t e to the minus st into f of t dt, and so on. Now put, this is somewhat important, carefully watch. Wait, now put small t equal to u plus capital T in second integral, not first integral. Second integral, here we have to put, instead of small t equal to u, small u is this one, plus t. And here u is not a unitary function, u is only a letter, okay, or so-called variable, u plus t in the second integral. So that implies dt equal to du. Now whenever we are going to change the variable, so obviously corresponding limits will be changed. So here you can see that for the second integral, when t equal to capital T is your lower limit, then u will be equal to 0, because we consider t equal to u plus capital T. So when t will be capital T, so obviously u will be equal to 0. T minus t will be equal to 0. When t equal to 2t, the upper limit, that implies, that means instead of t we have to consider 2t, okay, 2t equal to u plus t, so that implies u equal to t. Then consider small t equal to u plus 2t in third integral. So in this third integral, we are going to consider small t equal to u plus 2t. In a second integral, we considered t equal to u plus t, but for the third integral, we have to consider t equal to u plus 2 capital T, 2 into capital T in third integral. So dt equal to du, and the corresponding limits will be when t equal to 2t, u equal to 0, when t equal to 3t, u equal to capital T. Similarly, if we are going to consider t equal to u plus 3t, t equal to u plus 4t, and so on for fourth, fifth, and so on integrals. Here we just written second and third. For second integral and third integral, we substituted t equal to 2 u plus t equal to u plus 2t. But other integrals are there. That means fourth, fifth integrals are there. For fourth and fifth integrals and so on, we consider t equal to u plus 3t, t equal to u plus 4t, and so on. Likewise, the corresponding limits will be 0 to t. Okay. So now we are going to write by substituting the corresponding t values in those corresponding integrals. That implies Laplace transform of f of t. The first integral will be written as usual, that 0 to t, okay, 0 to t e to the power minus st f of t. Here same thing, it has been written 0 to t e to the power minus st into f of t dt. Then 0 to t e to the power, here instead of small t we have to put u plus t. So e to the power minus s u plus t into f of u plus t capital T into du. Then 0 to t e to the power minus s. Here we consider u plus 2t f of, instead of t we have to write u plus 2t into du plus so on. Okay. Then 0 to t, this one written as usual, e to the minus st f of t dt plus here e to the power minus su into e to the power minus st will be there, but integration with respect to du, so e to the power minus st can be taken outside of the integration, so 0 to t e to the minus su into f of u du, because why I am going to tell, wait, e 0 to t, then here we can found e to the power minus 2st, which is a function of t, can be taken outside the integration. 0 to t e to the power minus su will be there into f of u du plus so on. So here f of u plus t du is there. So f of u plus t, why and how it has been written as f of u, the reason here it is written that f of u will be equal to f of u plus t equal to f of u plus 2t, because initially we have been considered as f of t is a periodic function. So if f of t is a periodic function, so hence u also will be the periodic function, because here you can see f of t is a periodic function. So u will be small t minus t also will be a periodic function. Okay, u equal to t minus 2t also will be a periodic function, because I just subtracted t, capital T, which is the period of this function f of t. So obviously f of u also will be the periodic function. So if it is so, u plus t will be equal to f of u. F of u plus 2t will be equal to f of u, right? So that implies here, that means here it is written that f of u equal to f of u plus t equal to f of u plus 2t, because f of u is a periodic function. Here I am going to write, wait. So here I written as f of u is periodic, therefore f of u equal to f of u plus t equal to f of u plus 2t and so on. So that implies Laplace transform of f of t will be equal to 0 to t e to the minus st f of t dt plus e to the minus st into e to the t 0 to t e to the power, here e to the minus su is written as e to the minus st instead of f of u, written as f of t dt, du written as dt. Here e to the minus 2st is written here, e to the minus 2st, but wherever u is there, instead of u written as t, because u as a dummy symbol. So here in this expression, this is nothing but the Fourier transform of f of u. If I will change the symbol or letter u to t small t, it is, there is no changes. Okay, so as u is a dummy symbol, we can change this symbol or letter to another letter. So here another letter we consider as t, small t. So e to the power minus st 0 to t e to the minus st f of t dt, e to the minus 2st 0 to t e to the minus st into f of t dt. By considering u as a dummy symbol replaced by t, right? Next, here you can see that in each term e to the power minus st, e to the minus st is a common. Okay, see 0 to t e to the minus st f of t dt, this integral is the common integral for each terms. For this term this integral is there, for this term this integral is there, for this term also, and so on. So this integral we are going to take common. So what we are going to found, 0 to t e to the minus st f of t dt whole into, in your first term it will be 1, second term e to the minus st, e to the minus 2st, then e to the minus 3st, and so on. Same thing it has been written, 1 plus e to the minus st plus e to the minus 2st plus e to the minus 3st, and so on. Laplace transform f of t will be equal to 0 to t, this one, into this series is nothing but the Taylor series of 1 by 1 minus e to the minus st, because we know that the Taylor series about x equal to 0 of 1 by 1 minus x. The Taylor series of 1 by 1 minus x about x equal to 0 is nothing but 1 plus x square plus x cube, and so on. Already we have been studied in our fourth semester. So in this series, if I am going to put instead of x e to the minus st, then we are going to get this series, and this series can be written as 1 by 1 minus e to the minus st. Okay, considering the Taylor series about t equal to 0. For this case, about x equal to 0. So Laplace transform of f of t will be equal to 0 to t e to the minus st by 1 minus e to the minus st, hence proved. Okay. Based upon this expression, we are going to go for a numerical, is this one, that draw the graph and find the Laplace transform of the triangular wave function of a period 2L is given by this one, t in between 0 to L, 2L minus t in between L and 2L. So if I am going to draw this function, this is the graph. In between 0 to L, this is t. That means it will be increased up to maximum value. Then if I am going to put L equal to t equal to 2L, then this value will be 0. That means it is decreasing and will be, the value will be 0 at 2L. And this is periodic, means this function will be repeat after 2L. So 0 to L, this is the function. Then after 2L, it will repeat, means this function repeated, moving along the so-called x-axis. But this is considered as t, but along x-axis. So this is the graph. This type of waveform also called as sawtooth waveform. Okay, here I am going to write this type of wave or periodic function also called as sawtooth wave. Okay. Now we are going to find out the Laplace transform of this function. In general, we know that Laplace transform of a periodic function, if f of t is a periodic function, then the value is 0 to t. Here t is the period, e to the minus st into f of t dt by 1 minus e to the minus st. So as per the question, Laplace transform of the function, the period is 2L, so 0 to 2L e to the minus st f of t dt and 1 minus e to the minus 2Ls, because here instead of t we have to put 2L because the period of this function is 2L. Now Laplace transform of this function will be equal to, here you can see this integration with respect to t, that means this is the constant taken outside, 1 by 1 minus e to the power minus 2Ls 0 to L. This limit again segregated in between 0 to L, then L to 2L. 0 to L one value and L to 2L another value. So we have to separate the limits. First we have to write the value in between 0 to L. In between 0 to L, it is given that f of t is your t, and in between L to 2L, this is your 2L and minus t. So in between 0 to L, e to the minus st is there. F of t will be t dt, and in between L to 2L, e to the minus st into 2L minus t into dt. Now we are going to simple integration. Carefully you have to watch. 1 by this much written as usual, nothing is changed. And if I am going to integrate this one, we are going to use the by parts. By parts means if the first function is your t, written as usual t into second function of this second function is your e to the minus st. If I am going to integrate, then e to the minus st by minus s minus derivative of the first function will be 1. This function is going to integrate 2 times. So e to the minus st by minus s is there. Again, if I am going to integrate e to the minus st by minus s, so minus s square, limit 0 to L. Okay. Then here this one will be 2L minus t will be considered the first function, this one will be the second function. The first function with this one into integration of this one, e to the minus st by minus s. Then derivative of this first function, that means derivative of 2L is the constant, will be 0, minus t means minus 1. Derivative with respect to t of minus t will be minus 1. Already minus will be there, so minus into minus 1 into integration of this one 2 times, e to the minus st by minus s square, 0 to 2L is the limit. Carefully you have to put the limits. Here first we have to consider this one. Whenever we are going to put the L instead of t, then what is going to happen? Here L instead of t we have to put L into e to the minus sl or ls, written over here. L into e to the minus ls by minus s is there. Here e to the minus sl by minus s square also is there. Minus, here minus of e to the minus ls by minus s square is there. Then here written as 0. Why? If I will put 0, then minus of, we have to put 0 over here and 0 for this term. If I will put 0 for this term, here whenever I am going to put instead of t as 0, this term will be 0, so minus 0. Then minus of this term, already minus is there, so minus minus plus e to the power 0 will be 1 by, this is minus s square, means only s square, right? Then for this two term we have to put L and 2L are the limits. Carefully you have to watch. 2L, first we are going to consider 2L. Here 2L minus t, that means 2L we have to substitute 2L minus 2L into e to the power minus 2L or e to the power minus 2Ls by minus s is there. Then this is minus minus, means plus e to the power 2Ls, e to the power 2Ls by, this will be s square, minus s square means s square. Then minus we have to put L for these two terms. L we have to put over here, that means minus 2L minus L, 2L minus L into e to the power minus Ls by minus s is there. This is minus minus will be plus e to the power minus Ls by a square is there. Okay. Now 1 by 1 minus e to the power minus 12s whole into this one will be minus is there, so minus L into e to the power minus Ls by s. This term will be e to the power minus Ls by minus a square, means a square. This is 0 cancelled out, plus 1 by a square, and here this term will be cancelled out because 12 minus 12 will be 0, so this term will be cancelled out. So again we are going to write this term, so e to the minus 12s by a square, e to the minus 12s by a square. Here you can see 12 minus L will be L. Okay, 12 minus L will be L. So but here minus is there. Okay, minus, and here minus will be plus, minus, and this one minus plus, so plus here will be L e to the minus Ls by s, L into e to the minus Ls by s. Here minus, this is plus, so it will be minus e to the minus Ls by s square. So these two terms both are same but opposite sign, so minus and plus got cancelled. We are going to get 1 by a square, 1 by a square, 1 by a square, 1 by a square taken outside. Here 1 minus minus, here you can see these two terms, this one and this one both are same, so it will be 2 into e to the minus Ls, and this term is nothing but e to the minus 2Ls. 1 by a square is taken outside. So Laplace transform of f of t we found 1 by a square, and into this one 1 minus e to the minus 12s into this one. Here 2 into e to the minus Ls plus e to the minus 2Ls. So will be equal to, so here you can see that if these three terms will be written as 1 minus e to the minus Ls whole square, because here you can see a minus b whole square, that means a square means 1, square of this one e to the minus Ls square, that means this one e to the power minus 2Ls, then 2 into a into b, 2 into 1 into this term e to the minus Ls. So this can be written as 1 minus e to the minus Ls whole square. This is your answer. Another question, that find the Laplace transform of the function of half wave rectifier, that is f of t equal to sine omega t, which is in between 0 to pi by omega, 0 in between pi by omega and 2 pi by omega. The answer is this one. I left this question for you, you do by yourself. Okay, in our next class we are going to discuss convolution theorem, most important. Okay, so thank you so much for watching this video. Thank you.